This is section 2.4 in calculus. This is all about the chain rule, and I know it's going to seem like I say this all the time, but probably of all the derivative rules we use, the exponent rule, until now had been the most common. Well, the chain rule probably is the most common of all because it's kind of the more involved version of the exponent rule. So in general, the chain rule is used to find the derivative of a composite function. And that's only helpful if you know what a composite function is. So a composite function is like when you have a function within a function. So basically, if there is a parenthesis, then you're going to need the chain rule. So the rule is written this way, like the textbook rule is written this way. If y equals f of g, so here's the parentheses. So you have some function inside of another function. And so we would say that the derivative equals the derivative of the f part still evaluated at g, and then times the derivative at g. Now, it looks more involved than it really is to actually do it. So a lot of times the words that you'll hear me say, instead of the f prime of g times g prime of x, instead of saying that, you'll hear me say something like the derivative of the outside, and I'm going to write it this way, derivative of the outside times the derivative of the inside. And when I say outside and inside, I mean the outside of the parentheses versus the inside of the parentheses. So notice up here, the f is what I'm calling the outside, and the g is what I'm calling the inside. So the most basic example would be, if you look at number 1, so what's inside the parentheses is the 3x plus 5. That's the inside. The only thing on the outside is the 7. Okay, so the outside part would be, how do you handle an exponent of 7? Well, don't you bring the 7 down in front and you keep the base? It just so happens that the base is the g function. It is the entire parenthesis 3x plus 5. And finish out that exponent rule for the 7, and then you would decrease your exponent by 1. So all of that is what I'm calling the derivative of the outside. And then we want to multiply it by the derivative of the inside. Well, the inside of the function is 3x plus 5, and the derivative of that is just 3. So that's what we mean when we say the derivative of the outside times the derivative of the inside. Now, yes, you can clean this up and multiply the 7 and 3, and we would say 21 and then 3x plus 5 to the 6th. Okay? Derivative of the outside times the derivative of the inside. All right, so when I first look at number 2, you're thinking, well, I don't see a parenthesis. Well, you kind of do. Don't you really have a denominator of 2x minus 1 in a parenthesis that's being raised to the 1/2? So there's the parenthesis we're talking about. And at this point, I would still have to do a quotient rule, but what I could do is I could move the entire parenthesis to the top and look at it as 2x minus 1 to the negative 1/2. Do you see now it is a parenthesis with an exponent, and maybe really up here at the top when I said if there's a parenthesis, maybe I should say if there's a parenthesis with an exponent, because if all you have is a parenthesis and nothing happening to the parenthesis, then you don't even really need the parentheses. So anyway, sorry about that. So to come down here and work this one out, I'm going to say the derivative equals, so the outside is the negative 1/2 part, so bring down the negative 1/2, keep the base, which is the entire parenthesis 2x minus 1, decrease by 1, and it's negative 3/2. Okay, now do the derivative of the inside. So the derivative of 2x minus 1 is just 2. So if I'm going to clean this up, I'm going to say the overall derivative is, well, do you see that that 2 is going to cancel with that 1/2? So I'm just going to have a negative, and then because of my negative exponent, I'm going to move all that down. So it's going to be negative 1 over 2x minus 1 to the 3/2. Okay? Let's look at example 3. All right, when I first look at example 3, yes, I do have a parenthesis because of like what we talked about a minute ago, that 5x plus 2 is actually being raised to the 1/2. But do you see that we actually have a product here? So big picture is this is a product rule, right? 3x is being multiplied by this. As I start to go through my product rule, in order to do the derivative of the second, I'm going to have to use a chain rule. So this is like a chain rule within a product rule.
It sounds way more confusing. So big picture, think product rule. All right, so I'm going to say the derivative equals, derivative of the first is 3 times the second. So I'm just going to leave the 5x plus 2 to the 1/2 plus the first. And now when I go to do the derivative of the second, here's what I'm doing the derivative of. So I'm going to bring the 1/2 down in front, keep the 5x plus 2, decrease by 1 to the negative 1/2. That's the derivative of the outside, and I still have the derivative of the inside, so it's still times 5. Now let me make sure you see where everything came from. So let me back up. All of this second term is a part of my product rule. This was where I was doing my first times the derivative of the second, right? So what we were doing when we did the derivative of the second was right here. We were taking the derivative of the 5x plus 2 to the 1/2. So that's where the 1/2, the parenthesis to the negative 1/2, and then the derivative of the inside of that part was the 5. Okay, that was a bunch of stuff to put there. Now I'm going to clean this up. Here's what I have. I've got 3, and then that parenthesis to the 1/2. Now over here, I'm going to multiply this 3 and this 5. That's going to be 15 halves, and then I have an x, and then I have the parenthesis 5x plus 2 to the negative 1/2. Okay, so far. Now, I'm done with my derivative, but here's a situation where we want to get in the habit of simplifying by factoring, okay? Simplify by factoring. You may or may not remember, back on the prerequisites packet, we did some factoring where you had negative exponents. So here's what I want you to think about, okay? This is all one term, and this is all one term. And both of those have the parenthesis 5x plus 2. So there's a common factor of 5x plus 2. The only thing to think about is how much of that 5x plus 2 can I take out? And remember how we said you always take the smaller exponent amount? So the smaller exponent amount is going to be negative 1/2. Okay, so when I take that out of the first term, here's my first term. When I take that out of the first term, I'm going to have the 3. But because I had a positive 1/2 on my 5x plus 2, and I'm only taking out a negative 1/2, that means I still have some of it left. So how much? Remember how we said you take the original exponent, which was the 1/2, and then you subtract out whatever exponent you're factoring out. So I'm going to subtract out negative 1/2. And do you see that my new exponent is going to become to the first? And I know you don't have to write that. I just wanted to show you that it was a positive one. So all of that is from the first term, okay? And then I take my common factor out of the second term. Well, if I take out the parenthesis to the negative 1/2, what I'm going to have left is the 15 halves x. Okay, so am I done? Well, I can clean up a little bit on the inside, right? Let me kind of make this a little bit smaller, sorry. Okay, so what I've got here is I'm going to move that parenthesis that has the negative 1/2, I'm going to move that to the bottom. So I actually have this square root of 5x plus 2 on the bottom. On the top, I've got 15x plus 6 plus 15 halves x. Okay. Now, I have like terms, right? 15x and 15 halves x. So what I could do is I could add 15 and 15 halves, but do you see that I'm still going to have a fraction within a fraction? So I think what I'll do to clean this up so I don't have a fraction within a fraction is I'm going to multiply the entire numerator and the entire denominator by the common denominator, which is 2. Remember how anytime we have a fraction within a fraction, this is an easy way to simplify. So on top, I've got 30x plus 12 plus 15x, and actually, well, I'll go down here. And then on the bottom, I just have 2 times the square root And then actually, do you see that on top I have 30x plus 15x, so I can go ahead and combine those to be 45x. So I'm going to, just because I'm out of space, I'm just going to change that 30 to be a 45. Okay, so this is my simplified answer. But make sure you notice the chain rule, the only part of this that was the chain rule was right here. The rest of it was us, well, there was a product rule, but the rest of it was us just doing algebra. Now, will every problem need that kind of algebra? No. But when it does, you need to know how to do it. And it will happen, sometime on the AP exam, here or there, throughout this year, you're going to have to dig in and do that kind of algebra. Okay. So let's look at number 4. Now, I've done 3 examples that had a chain rule involved. None of them had trig. Okay, so let's talk about for trig. Well, it's not like it's a different rule if trig is involved, but sometimes it's hard to tell where the parenthesis is. I'm just going to make this a little bit smaller so it's kind of not in my way here. Oh my. Bring that over there. Okay. So it's just kind of hard to tell where the parenthesis is. So just make sure you can always identify where is that maybe sometimes hidden parenthesis. So on number 4, the parenthesis is not hidden at all. Okay, so the inside is the 3x and the outside is the cosine. So when I do the chain rule, I'm going to say the derivative of the outside. So the derivative of cosine is negative sine of the same angle, right? Because the derivative of cosine 3x is negative sine 3x, okay, of the same angle. And then now I'm going to do the derivative of the inside. Well, the derivative of 3x is just 3. So my overall derivative is negative 3 sine 3x. Okay. Now, number 5, you might be looking at this saying, well, there is no parenthesis. Well, there is, but it's kind of an implied parenthesis. Do you see that in this case, this is the same as the entire sine x function being squared? So I've identified where that hidden parenthesis is. So now when I do the derivative, in this case, do you see that the outside is the exponent of 2 and the inside is the trig function? So notice on number 4, the outside was the trig function. On number 5, the trig function is the inside. Okay, so the derivative of the outside, so 2, keep my base of sine, decrease it by 1, so it's to the first. Now times the derivative of the inside, so the derivative of sine is cosine. Okay, so that's my derivative. And as far as the homework is concerned, I would just completely leave it like that. But I have seen this show up as a multiple choice on an AP question. And I can tell you right now, that was not the choice. On the AP exam on multiple choice, they changed that using the identity. Isn't that the identity for sine of 2x? So you might be saying, oh, I would not have noticed that. That's why I mentioned it, because you need to start getting more familiar with that sine of 2x identity. Okay, so let's look at number 6. Okay, well, do you see that this is a combination of number 4 and 5 in that, yes, I have a parenthesis, but notice there's an exponent on the cosine function. So I'm going to rewrite this. This is kind of like saying I have the cosine of 3x and the whole thing is squared. So do you see that in this case there are 2 parentheses? Okay, this is kind of, not that you have to write this down, but it's kind of this scenario where you have an f of g of h. It's kind of like a function within a function within a function. So again, you just start on the outside. So when I start to do my derivative, the outside is going to be the 2 part. So bring down the 2, keep the cosine of 3x. Now it's to the first. So it's kind of like having that whole thing to the first, right? I'm not going to write that because it makes it look more complicated. But so I took care of, let me go here. I took care of this part. That was my outside. That was my derivative of my outside. So now I'm going to go in and multiply by the derivative of the inside. But in order to do this inside, do you see that it is its own chain rule? Because the cosine is going to be the outside and the 3x is going to be the inside. So I'm going to say the derivative of cosine is negative sine of the same angle, and now times the derivative of the inside, so times 3. So do you see that in this case, I had kind of a 3-layered chain rule. Now I could clean this up a little bit, and I could say, all right, my overall derivative is this 3 and this 2 and this negative. I'm going to put out here as a -6. And then I have cosine of 3x and sine of 3x. So that is my overall derivative. Okay, so this next part, the part that I'm calling the critical thinking, we really kind of already did a dive into this in the last class, but let me just kind of show you how we can kind of bring it all together and then include the chain rule in some cases. All right, so I've got the graph of f and g. So the red one is f, the blue one is g. Number 1 says, let h equal f of g. Okay, let h equal f of g, and then c equals g of f. Okay, use the graph of f of g to evaluate each of the following. All right, so h prime of 10. Remember what I told you guys the other day. Before I can find h prime of 10, I have to find h prime of x. Well, if h is f of g, that means I'm going to do the chain rule. It's going to be the derivative of f evaluated at g times the derivative of g. I mean, that's the exact rule that we wrote, when we first, set up the chain rule. All right, so that means h prime of 10. So I'm going to replace an x everywhere. I'm going to put it in a 10 everywhere I see an x. So I've got f prime of g of 10 and then g prime of 10. Okay, so let's start right here with this g of 10. Well, g is the blue graph. G of 10 is right there, and the value of that is 1. So I'm going to replace this whole thing with 1. So I actually have f prime of 1. What about g prime of 10? Well, that would be the slope right here. And do you see that the slope of that segment is -1? Okay, so I've got one last piece I need to come up with right here. What is the derivative of the f graph at 1? Well, the f graph is the red one. So what is the slope of that f graph right there? Isn't it down 2 over 1? So I think this is going to be -2. And remember that -2 is being multiplied by -1 for a total of +2. Okay, and this is what I told you guys last time, that after that COVID year, they started doing this FGH business quite a bit. Okay, so I'll kind of file that up here. So how could I save myself a few steps? Well, I mean, I can cut out a little bit. I know that C prime, or C of x is g of f. So before I can find C prime of 9, I have to find C prime of x. But I could go straight to plugging in a 9 everywhere I see an x, right? So I'm going to say the derivative of the outside, so g prime of f. And instead of saying of x, I'll say of 9 times the derivative of the inside, which would be f prime of, instead of x, I'll say of 9. So this was me setting up my derivative, but also plugging in 9 at the same time. Okay, so let's start on the inside. In place of f of 9, so let's see, f of 9. So my f graph is the red one. Of 9 would be right there. F of 9, it looks like, is 8. So I've got g prime of 8. All right, well, what's f prime of 9? Well, the slope of that red graph at 9, I believe, is +2. Okay, one more piece, g prime of 8. So go to where x equals 8. See where that hits the g graph. That's the blue graph. The slope there we said was -1 times 2 is going to be -2. Okay, so that's kind of how this critical thinking applies to a chain rule, but let's go ahead and do the next one. So q prime of -1. Again, remember what we said. Before I can do q prime of -1, I have to do q prime of x. So I think what I'll do is I'll set up my quotient rule, and at the same time, I'll just plug in a -1 everywhere I see an x. So it's going to be derivative of the top at -1 times the bottom minus the top the derivative of the bottom at negative 1 all over the denominator at negative 1 squared. I like at a minimum to do that part of the setup. You may remember in class the other day, I told you guys this is the minimum first step for this type of a problem. And now we're going to go and just fill everything in. All right, so let me get rid of some points here. So let's see. We are looking at negative 1. So here's negative 1 on the f graph. So f prime of negative 1 is negative 2. G of negative 1, we're going to have to estimate, what do you want to call that, 3.2 minus f of negative 1 is 6. And then the derivative of the G graph, it looks like, if you think about it going from here to here, it looks like it's up 1 over 1, 2, 3, 4. I think that's going to be a positive 1/4. And then all over G of negative 1 we had said was 3.2 squared. And because we had to estimate, this isn't going to be very pretty to simplify. But remember what I said, if this were a free response, it would be perfectly fine to leave your answer unsimplified like that. Okay, so normally in homework I would say, yeah, simplify just for the practice of it, but just because we have decimals, we're going to leave it as is. Okay, letter D, find P prime of 1. So can you handle this? Let's go straight to our product rule and plug in a 1 for everywhere we see an X. So we're going to say P prime of 1 is derivative of the first times the second plus the first derivative of the second. Notice instead of at X, I replaced all of those with a 1. Okay, so let's fill in our values. So the derivative of P at 1 is, okay, I like to kind of put a point up here so it's easier to identify. So we're looking at X equals 1. So here we are on the F graph and the G graph. Okay, so let's see. F prime of 1, I believe the slope is negative 2. G of 1, what do you want to call that? 3.8, I have no idea. I mean, you might call it something different. That's okay. Plus F of 1 is 2. And then the slope of the G graph, well, on the previous problem, we said right there it was going to be 1/4. And I know I've got decimals here, but I could do some cleanup. I could say 3.8 times 2 is 7.6 plus 2 times 1/4 is 1/2. But if I write it as a 0.5, then I could easily simplify this and say negative 7.1. Now, if you had estimated G of 1 to be something different than 3.8, then our answers might differ. But this just kind of shows you that you can still simplify this pretty easily. Okay. Look at letter E. Letter E has something that looks a little different. It says, find m prime of 2 if m of x equals this. Well, do you see that this is a function within a function? It's kind of like they're saying, hey, it's f of g, but g is x squared. So if I set up my derivative of m using a chain rule, I would say derivative of the outside, still evaluated at the original parenthesis, then times the derivative of the inside, which would be 2x. So if I want m prime of 2, it's going to be f prime of 2 squared is 4 times 4. Okay, well, what is f prime of 4? Let's see. On the f graph, here we are. F prime of 4, I believe, is up 1 over 2, so 1/2. And then times that 4 equals 2. Okay? And one last critical thinking. Find the equation of the line to h of x when x equals 10. You know what? This should say equation of the tangent line. Sorry about that. Equation of the tangent line. All right, so that means not only do I need the ordered pair, 10 comma something, but I also need to know what is the derivative of h at 10. Okay? Well, remember up above, they told me that h of x is f of g. right? They told me that up in the original directions. So if I need to find this y coordinate right here, that means I need to find out what is h of 10. Well, wouldn't it be f of g of 10? Well, what is g of 10? Go up there. G of 10 is 1. So really this is like saying f of 1, right? Because we just said g of 10 is 1. So what is f of 1? Let's see, the f graph is red. F of 1, I believe, is 2. Check my work, but I think that comes out to be 2. So that means the ordered pair I want is 10, 2. Notice how I've showed my work here. This is a very common kind of free response. Again, notice what I'm doing. I'm kind of showing my work. And now I need to find h prime of 10. So remember how up here we said, here we go, up on letter A, we said h prime is f prime of g times g prime. Well, and we even found h prime of 10, right, to be 2. So I can pull that down. I can just use that 2 in place of h prime of 10. And now I'm ready to write my equation for my tangent line. So I'm going to say y minus 2 equals the derivative, which is 2, and then x minus 10. Okay? So that is section 2.4. It's got not only the new rule, but there was a bunch of algebra packed in, and then we kind of talked through some critical thinking. So there's quite a bit to kind of take in. The best way to get good at this is just to jump in and to practice. Make sure you're very conscientious about this homework, and then make sure you check your answers with those provided, and you come back with specific questions, and we can kind of talk through as much as y'all may need to in the next class.